Welcome to our webinar, Developments with Maritime Digital Modelling in Greece. Our guest speakers today are Nancy Dandolos, Commercial Director, Southern Europe with the Signal Group, and Pantelis, COO at Ulysses Systems. If you have any questions about the topics today, please type them in the Q&A section and we'll get them answered for you at the end of the presentation. Here is our host, Carl Jeffrey from Digital Ship to explain more.
So our topic today is digital modeling in shipping. So by this, we mean building digital tools which are modeled or closely aligned with the complex working processes of shipping. So this is the third of 4 webinars we're doing about digital modeling and aligning software with processes over January to March. And today's webinar is showing technology from Greece. So the reason we're doing these webinars is a sense that the shipping industry could be doing a lot better with having digital technology which fully supports the way we work with the technology building blocks that are available to us in 2024. So as an example, think about purchasing for ship operations. We've had procurement systems for years that basically treat all purchases as the same, but from a ship owner's perspective, the factors involved in a decision to purchase bunkers or to purchase spare parts are completely different. And the ideal digital tool would integrate handling the procurement with tools we use to support our work and decisions in all the other areas relevant to the purchase. Or if you consider a ship owner deciding whether to accept a cargo, we've had systems for years which will try and work out if a cargo will be profitable, telling us the costs of running the ship. But the ship owner is really thinking about whether this is the best cargo that the ship can get or whether the ship is the best that the charterer can get. And if there's any extra costs involved in taking the cargo. So that means you've got to have knowledge about all the other possible cargoes or knowledge about what other ships might be available to take them and what extra costs are associated with carrying the cargo, such as a ballast trip to pick it up. And the ideal tool would tell us about all of these things. So we've got 2 companies presenting today based in Athens who've gone, I think, further than most in developing tools to support full shipping processes. First, we'll hear from Ulysses Systems that supports ship operations. Then we'll hear from Signal Group, which supports commercial decision making. So Ulysses Systems has a service to integrate together multiple software systems in a much deeper way than using APIs, because APIs are written differently for every piece of software. But if you've got lots of software tools to integrate, learning all the APIs gets very complicated. So perhaps there's a better way of doing it. And our speaker is Pantelis Panteli, who's the Chief Operating Officer of Ulysses Systems. And second, we're going to hear from Signal Group, a company that's built the Signal Ocean platform that supports decision-making by charterers, brokers, and owners. And you can bring together your own commercial data with purchase data and public data, and it's all presented in the best way to support a decision. And behind the service, the complex forecasting models and methods to bring data sources together. And we're going to hear from Nancy Dandolos, who's Commercial Director, Southern Europe with Signal Group. So we're going to have 2 presentations of about 15 minutes each from Pantelis and then Nancy, and then we'll take questions from the audience, and you can put your questions at any time in the Q&A box, and we'll take them at the end. And I'd like to invite Pantelis to start his talk.
Thank you very much, Carl. Good morning to everyone. I'll try to keep this as simple as I can. We're going to be talking about modeling and goal models today and why we need them. As an engineer, I grew up with a lot of modeling around me. At university, we looked at models to solve problems in thermodynamics, entropy, things like that. I remember the very first time I really thought about a model was trying to solve a problem with some hot ethylene going through a pipe. And all of us modeled the situation. Some of us used Pascal, a few others used Fortran. A colleague of mine used C++, but he was just a show-off. And I remember I used Excel, if I'm not mistaken, because it was quicker and then you could reuse the model a little bit easier. But the goal was the same, to try to understand how the liquid ethylene passes through a pipe and how thick the pipe has to be so that it doesn't break. So we all had exactly the same model of how it works, exactly the same rules, but we implemented them by different technologies. But the key was the model, and the goal was to ensure that the whole thing doesn't blow up in your face. And then I was very fortunate enough through Dimitri to also meet some very, very important people in cognitive science, Roger Sank being one of them. And I'll never forget the first day I met him. And then realized that modeling is everywhere. And, you know, even dogs model how they would go about a walk. We model how we cross a street. You know, for example, we understand crossing a street in Australia in the same way as we understand crossing a street in Egypt, in Greece, in Mumbai, in New York. You know, the goal is to go across to the other side safely without causing an accident behind you or without sort of getting run over. So all these things are inherent to us. And then we go into the software world. I remember at university, we did a lot of modeling on how to set up an assembly line. So, and then we start working in software and where you have deadlines and things like that. And all of a sudden we forget all this. And we develop a feature. We think it's a brilliant feature because we got our best developer, our best analyst, and our best client to develop the feature. You develop the feature, and as soon as you put it on somebody's desktop, you realize that it's missing 3 or 4 or 5 key things because you never thought about all the things that you didn't put down on the paper. And you were using a modeling technique like rational rows or UML. But again, because this is just a little bit of the entire process and why you develop things, you still lost the important things, which is that you did your transaction, the transaction worked, but then you never thought about all the what ifs of the transaction and how this transaction affect other things. And all of a sudden you're not getting the value. And then you have to develop and redevelop the same feature over and over again. We came, of course, across this problem, and eventually we managed to solve it. And how did we solve it? Through modeling techniques. Some really good examples of why you need modeling, because a lot of people think of software being just a transaction, which is like a purchase order being approved. You know, there's a lot of software now that's coming into navigation. How do you model the navigation? How do you develop a navigational process software using business object? How do you describe the captain being tired with a business object? How do you describe a fisherman coming across your bow with a business object? How do you describe a tired third officer who's thinking about a problem at home while you are navigating through a narrow channel weather? All these things are very difficult to describe using business objects, but they're quite easy to describe through modeling because you can do a cause and effect model where you can see that if the third officer is tired, you can actually identify how it will affect your navigational process. Another example of modeling that we use to solve problems is defects. Defects on a ship could be a breakdown, but quite often when we use our traditional defect tracking system, all you do is you understand a broken, for example, sorry, lots of people are calling me when I told them not to call me. Switch everything off. So another typical example of modeling is a defect tracking. Quite often when you track defects in software, all you're doing is to see whether you closed it and put all the paperwork together. And you avoid the key issues of a defect. Why did it happen? What is it going to cause? What are the follow-up threats? So a small defect to a little pump somewhere in your engine room could actually be a pump in your rudder, and then you could lose your navigational and maneuvering functions of the ship. So you need to be able to model a lot more in what you're doing than just the process, which is quite often the problem in software. A third example is a modeling and integration between, say, an invoicing system and an accounting system. Quite often, when it comes to integrating those two, you use an API, and the API will describe a PO, how much it costs, what is the name of the purchase order, what is the name of the spare part. What it does not do is it does not explain why you are making the integration and why you have invoicing. You have invoicing to avoid double payments. You have invoicing to avoid paying the wrong person. You have invoicing and you have things like pro forma payments and stuff like that. How do you describe those in just a traditional API when the API usually just describes what is a spare and what is a purchase order? So being able to try to identify what are the goals and what are the risks at the end of each process that you try to model in software is the key to successful software. And to follow up a little bit with what we did a few weeks ago with, there was a very nice presentation by Lene, where they, from Vesselman, they are some partners of ours that we have done an integration for the dry docking module. I have a little set of presentations on PowerPoint that I would like to share with you, just to try to explain and follow up from the previous webinar about modeling on how all this works. So let me just find my PowerPoint, or just give me a minute to start my PowerPoint going. So what I would like to do is I would like to share, if I manage to share what I want to share, let me just go back. Then press on this. Okay, so here's a little bit more technical now, but it's more realistic. Here, what you can see is how we have developed a model on how to pass data from one system to the other, and how the developer can actually see the different data points being highlighted on the data that crosses from one system to the other. What you've done is on the left, we have described what is the real life process of the dry docking. And on the right, you can actually see the data moving from one side to the other, and you can actually trace it and understand where the problem is. Describing also how the real world works helps you a lot with also understanding what are the features that one system support and what are the features that the other system supports. And then you can actually see the gap between the two, because the API usually tells you what the software does, whereas modeling how the real world works above the features and the APIs, you can see what are the missing points. So for instance, here we managed to, when we did the integration with Vesselman, to be able to understand how we are going to handle data that never started from our system, like somebody in during a dry dock putting an ad hoc job inside Vesselman that never existed in our system. How would our system handle it? So we modeled all that. And then you can see here a little bit of a more of a technical schematic on how you can actually trace the logic and how the client can actually understand exactly what your software does. The good thing with modeling is that when the developer sort of stops the modeling and disappears, goes and works somewhere else, you still have all the real life processes that your software works in a clear and visual method, so that you can have a continuity without worrying on whether the developer remembers what they did or whether you have to hand this job to a different developer. And there's another example here. I think this is a little bit more interesting because as we have Nancy speaking to us later on, recently we integrated our PMS system with, how shall I put it, an operations module. And what this does is that and an email system as well. And what we did is we looked at condition-based jobs that you need to do on cycles, like, for example, pre-arrival technical checklists in the engine room, and pre-departure checks, or pre-starting checks for a pump, or post-starting. So what we did is the system can pick up either from the operations module when the ETA is, the estimated time of arrival, or the estimated time of departure. And the day before you actually arrive or depart, the system will look at the emails and pick up the ETA, or will look at the operations module for the same date, and will immediately alert the PMS system and create notifications for you to do your pre-arrival or pre-departure engine room checks. Here I have another example of what is the whole cause and effect model. This is what it looks like. And you can see you can go as deep down as you like into the model, or you can go all the way up to the high-end processes, which is to generate revenue, for example. But you can see how a little problem on a little bit of a machine, how you can actually trace how it will propagate and how it affect more sort of important processes for senior people that do not necessarily care about a little problem that's happening to a machine. Okay, and this is basically my presentation. I'm gonna stop sharing now. I hope I stopped sharing. Have I stopped sharing? Yes.
Yes.
Okay. And I think I'm going to leave it to Nancy to continue. And then I look forward to some questions.
Oh, that's great. Yeah, I don't know how good this analogy is, but I'm thinking when you go to Amazon, you have a system to choose what you want to buy, and then you have a system to deliver the book, and they're all fully integrated, and that's exactly what we expect. So what we're seeing here is what it's like in shipping. I guess Nancy is the commercial side buying the book, and Pantelis is delivering the book, which is delivering the ship, and somebody might reasonably expect shipping systems to be as integrated as well as Amazon is, and of course they're not, but hopefully they're going in that direction. So I shall pass over to Nancy from a Signal Group to show how the commercial side can work.
Thank you, Carl. I like your book analogy a lot, actually. As you said, can you all see me? Yes.
Yes, can see you. Can't
Okay.
see your screen yet. Yeah.
No, I'm not screen sharing yet. Okay, so I do like your book analogy a lot. I think what I'm gonna try and show here is how that book that we end up buying is the correct one. So let me start with sharing my screen. You guys can see my screen?
Yep, all good, yep.
Amazing. Yeah, so I will start off by giving a bit of a background into who we are over at the Signal Group and what we do to help you understand how we use technology. So there's three entities that make up the Signal Group. There's Signal Maritime, which is a shipping company with an MR pool and an Aframax pool. They are the brains behind the operation. So they bring the know-how of the shipping industry to us. I belong to Signal Ocean. Our main offering is the Signal Ocean platform. Our clients include brokers, owners, and charterers, basically people in the shipping industry looking to fix vessels, looking to check profitability, monitor cargoes, and what have you. And there's also our Signal Ventures arm where we incubate companies that have to do with shipping and technology and logistics, and so on and so forth. So the problem that we started off with, and we were at fault of doing this ourselves when we first started building the Signal Ocean platform, because we are so much into technology, we are so much into innovation. We focused a lot on technology, and it was almost like we were doing technology for technology's sake. The platform has grown through the years to be a lot more customer centric. Okay, so when you're thinking more about technology than the problem you're solving, than your customer, then you can you can end up with a disconnect between the software that you've built and the actual need that arises from the processes that are in place in the industry. Why is being customer centric important? Because at the end of the day, this increases user adoption. So we're in the business of selling software. So user adoption is essential to us. So if we cannot get somebody to like what we've built, then it's a loss for us. And so we aim to create a solution, understand the problem that people are facing based on the processes that are in place in the shipping industry, which is a very traditional industry, technology-wise. So we try to align all of those with, adopting the product and then growing and becoming more efficient. So as I said, the challenge of the maritime industry is that there are a lot of what we call core shipping goals. So the buying of the book, in essence, that Carl mentioned. So you get people in shipping companies, the chartering departments of shipping companies that are always on the lookout for profitable cargoes. They want to charter the vessels at the best rates, manage their fleet. Now you have a lot of things coming into play as well, emissions and compliance, and everything else that's new like that. So the issue so far, the challenge is that there are a lot of softwares out there. There's a lot of softwares out there, purchasing management, crew management, but it's almost a one size fits all approach that kind of doesn't help the individual at the end of the day with the struggles that they're dealing with. So it's as if you're trying to fit the individual and their problems into your software instead of the other way around. So we at Signal, as I said, the important thing I think that differentiates us is having the fallback of Signal Maritime. So we first looked at Signal Maritime and the problems that they were facing with all the processes that were in place. So as I said, shipping is a very traditional industry. A lot of things were done by hand. A lot of things, if there's any people that do chartering in the audience, you know how painful it is to even make a list and count commercially available vessels within a region. There's a lot of data that everybody's sitting on that people don't do anything with. So a chartering department gets bombarded with a lot of emails during the day with positions and cargoes and fixtures and what have you. And people are kind of hoping for the best. You have all of the data that is going unused, and you're kind of hoping, I'll skim through my mailbox. And I think if I describe this, it's a pain that everybody feels within the chartering industry. You get so many emails, you skim through, check out your 3-4 favorite brokers, see what they say. You're consciously missing out on information, but that's the best that you can do. So this was one of the biggest pain points that we found, and we decided to approach this using technology. So what we say we do is we fuse, as we say, commercial data, people's commercial data. So your cargoes, your lineups, your fixtures, your positions, and everything like that. We fuse it with AIS data. So at the end of the day, what the user can do is very simply and easily, using an interface that's online, figure out how many vessels are available, commercially available at a certain region, how many cargoes are coming out of a certain port, how many vessels are ballasting towards a certain port. So trying to do this very simply by processing the information that the user already has that he cannot do anything with at the moment because it's just so much and the technology isn't there. We digest that information and then we kind of serve it back to the user in a user-friendly interface. So we have built the platform tailored to address the needs of the industry. Okay, so we're trying to help people count vessels in a smart way. We're trying to help people understand supply and demand. And this all fits into their existing workflows. So if you're part of a chartering department, understanding supply and demand in your area of where you're currently working on is very, very important. This is what helps you, get that competitive edge. So we use that, focusing on the processes that people have in place and try to make things easier and allow our clients to gain a bit of a competitive edge by using that technology that we offer. So how do we do it? So we, as I said, we combine commercial information. So there's all of the data that people are sitting on. We combine that with AIS data. So in essence, you don't just know that a vessel is in the middle of the Mediterranean Sea because the AIS tells us so. So there's plenty of software out there that can give you the position of a vessel. But what we do is we integrate the commercial data and we tell you that vessel is here. Why is that vessel here? Because she speaks forward to load at this load port, discharge at this discharge port, because there's this fixture in place with this charter at this rate. So you get a 360 view of what a vessel is doing, and what a vessel is doing in her next voyage. So the system will know, and this all stems from the data that people are sitting on already. Okay, so the platform will then tell you very quickly. You just ask it questions, and it will respond, and it will tell you this is how many vessels are commercially available. So it's you and another 15 guys trying to get this cargo that is coming out of Turkey, for example. This is very important information to have, and this is all live, and this is all updated live. So as the information is being read automatically, and we have a patent in the US for our scraping of emails, as we call it. So this is read automatically, and then the system updates and says this vessel is available. This vessel has just been fixed. And then all the user has to do is, with a few clicks, get a view of what the market is doing. Okay, so that optimizes your workflow at the end of the day. So you have lists specifically built for your areas of interest, depending on where you're focused on. These get updated automatically. So it's an interface that's very easy to use. And at the end of the day, you just monitor how the situation evolves. Then you can spend time that you would usually spend trying to read emails to, speak to your broker, to have more meaningful conversations with people in the market, instead of, trying to trace where vessels are and then, track if a vessel has come into port or not. This is something that we cover as well. So on top of everything, we cover all of those daily activities, but then the industry is thirsty for more information as well. So insights into how markets are moving, okay? So we focus on the daily activities, but we also go high level as well. And then you have the option of, looking at what has come out of a certain port within the last 6 months. That gives you an idea of how that port is going to perform in the next couple months, okay? We're not going to ever guess what's going to happen 6 months from now. If we could, we'd be raking in the money, I expect. But the way we approach this is looking historically at all the data, and then trying to analyze and then give people insights or signals, hence our name, into what might come in the future. This all fits into the processes that chartering departments have in place at the moment. So counting vessels, we just count vessels in a more smart and efficient way. Monitoring supply and demand, we follow that process as well, but we put the data behind it, we put the numbers behind it, and everything else. So we give people back clear insights to better understand the shipping landscape and make decisions based on that. And I think that is me done.
Wow, well, thank you very much, Nancy. Okay, so we'll go to the Q&A session. We can see one question in there so far from Marco, but I don't know if you both want to bring your cameras on now, Nancy and Pantelis. And just a sort of warm-up question for me. Is this stuff getting easier? I mean, it's obviously not cheap building digital technology, but people say it's got easier to bring technologies together over the past year. Do you have any perspectives on if it's getting easier, or maybe it's slightly easier than it used to be? Or I don't know. Maybe start with Nancy.
Do you want me to start, Nancy? Can I go first? Whether we like it or not, we are going to do integrations. Every competitor is a potential partner. IoT has changed the way the world works, and we've got to allow for little clever tools that solve specific process problems to be integrated in your system. And the only way to do that is by, as far as we are concerned, is through modeling. If you the only thing which is standard, and this also goes to the question that Marco also gave to me, the only thing which is standard is how people work and how the world works. Everything else is just software that fits into it. And the better way, the better you model and you fit the software into understanding how the things work in the real life, the less trouble you will have with software and the easier it will be to develop it. So that sounded like a sermon, but I sorry.
Nancy, do you think this stuff is getting any easier? Yeah.
I think for us, it's gotten a bit more difficult because we started off focusing on tankers, and for us jumping into other vessel segments like dry bulk and containers and LNG and LPG. It's kind of starting at the beginning and building and understanding those processes and modeling our platform to align with those processes. So yeah, I think, but I guess we'll get to a point where we've done that, and then it gets simpler. But at the moment we're still growing, so it's still an effort.
Yeah, well, I thought there's a sort of small difference in so Signal Group, you're mainly integrating with email and data sources, whether Ulysses you're maybe integrating with other software. I don't know if that's true or well, I suppose it's a slightly different challenge, but still roughly the same thing, is bringing lots of data and sources and activities together.
Yep.
What I think is important is that all these data lakes, data marks, data oceans, I don't know what is the next version, is that people are starting to understand that collecting your data is important. Now we have to find ways to see how this data affects what you do in your real life. And unless you understand what are the goals you have to solve with real life and you can implement them in software, then you could have confusion with too much information. It's okay for a supermarket to analyze massive amounts of data to understand when people buy baked beans and you have to put baked beans on the front of the counter, or sort of chewing gums or razors just before you pay your bill. But for more complex situations like the problem that the Signal are trying to solve to try and help the owners have the right ships at the right time with the right cargoes and stuff like that, all these things require modeling. And as we are trying to integrate our processes and we make real integrations of software, modeling helps. I mean, a typical example of modeling within what we are doing is that when you build a new feature to an existing feature, it's like integrating two software together. So again, you have the old features and you have to add a lot more features to the original way that you handle spare parts to also include cyclic components that you change between units. Then what you do is you model the whole of the process. You see what is the old software and how the old software data fits into the process. You see where the gaps are, and then that's how you develop the additional features that go on top. And that's how you have efficient engineering, where you have less testing, less iterations to get to your goal. And you also have in mind other problems that you might want to solve later that will not require you to redevelop things. So quite often you can't develop everything, but if you don't know what you don't know, you might get stuck and you might have to go all the way down to the bottom and redo the whole lot. So modeling helps in many ways.
Wow. I've just got an interesting question from Tassos Makris of Gordon McAllis Maritime, but he's saying about the language used to describe processes. Human language is not unambiguous enough to describe a process. Will AI solve the problem? So my answer to this would be that the best we have as people is our human language and ability to communicate, and there's nothing that computers has ever come up with that's anywhere near that. And but people could charter ships quite happily before computers. It's just bringing the computer into the people world. I don't know. It's maybe a bit of esoteric point. Nancy, do you have any thoughts on? I mean, it's computers following people. That's what it's.
Yeah, I would agree. AI improves, every single day. But I think the native language is so complicated that inherently I don't think we're ever going to catch up. It's always going to be a step ahead.
To add to that, each vertical business has its own causality and cause and effect model. And most of the AI is not built for understanding the specific cause models of a specific industry. So, I use AI on a daily basis to rewrite marketing text. So what I write something, and then I ask it to write it as if I were Steve Jobs selling to superintendents. It does a brilliant job with rewriting things like that very quickly and nicely. But if I tell it enough times that humans have a green skin, eventually it will start talking about my green skin. Yeah.
I mean, people are very, very good at communicating, and particularly in shipping where it matters, aren't they? I mean, and that's how our whole industry works, from people and their communication skills, I suppose, isn't it? But but people don't have the awareness that they need to make the decisions. So the core problem is processing information or putting the right thing in front of people, not communicating, I would say. I think that goes with both of what you're doing, isn't it? Yeah. And then, so it's from Marco Vattaroni. So people often talk about standards as a solution to everything in shipping, but the standards take so much work and effort, and they don't always work. And modeling is making something around somebody's unique needs. So he's saying, what's the difference between modeling and standardization?
Okay, I think you start with modeling the world, and then you make standards to fit the world. Shiptex is a wonderful system, and we can fit it into our modeling any day you like, just like you can fit into it a standard book by Burmeister and Wine. The key is to be able to understand how the different the shipyards build the ships, and understanding how the different manufacturers build the spares in different subcontractors, and how they sometimes want to hide the original part number so that you buy them through a consolidator. And being able, once you are able to model all that, then you come up with, you can fit in a system like Shiptex very well into the system. And you can also grow outside the Shiptex, features that Shiptex might not cover, or features that Shiptex covers that we don't cover, into how you describe a book. So all these standards that come after modeling are certainly help the industry in solving a big problem, which is data population and maintaining unique IDs of spares on board the ships, because that's the main reason why a lot of ERP systems fail, in that, you know, every 6 months you have to do your spare parts catalog. So that is a typical example of you not modeling the world around spares well, and that's why you have to do so many workarounds when you use the software, and hence you end up having to redo the data population every 6 months, which is very, very expensive. It stops the continuity, it stops good reports at the end of the day. So there's a lot of things and effects by that are very, very negative in shipping if you don't do the spare parts well.
Wow. Well, we've got a specific question from Nancy from Vittorio Lippe, who's IT department at the International Institute of Chartered Shipbrokers. Can you make and provide forecasts about future fleet positions, what ships are likely to be where and when, and how much in advance? Well,
Yeah.
Well,
So answer is a bit complicated. So what we do, first of all, by being able to pull all of the data from the emails, so looking at which vessel is fixed, which vessel is available, we can very successfully predict the next open position of a vessel. Okay, so we're focusing on the spot market. So we're looking at things voyage per voyage. So we can grasp from all the emails the next open position of a vessel. But we have, since we first began, we have really built up our analytical side of things. So using all of the data that we're sitting on, we can look into the future. The way we look into the future is by looking at the past. So we have like data going back to 2014. So we can see, you know, if your question would be, what is going to come out of the US Gulf in the next 6 months? We look into what has come out of the US Gulf in the last 3 years, and then try to find trends within that period and figure out what's coming next. So yes and no to your question is the answer. We are not going to tell you there's going to be 15 vessels opening on June 21st, 2024. That would be, you know, that would be amazing. But we can tell you, you know, June, same day last year, there were that many vessels there. June 2 years ago, there were that many vessels there. In the last 6 months, this is how the market has evolved. So we give you all of that information, pull it from the data, and you can very easily identify, as I said, trends or signals into what is going to come in the future. So yeah, we do monitor, and we bring a lot of factors into the equation. So, you know, we monitor vessels that are commercially available. We monitor cargoes, you know, so you look at what has come out in the sense of cargoes out of a specific port. You look at the seasonality, especially in the dry bulk sector. And then you count vessels, how many vessels are heading there, how many vessels were there same day last year. And then you can say, we're now in the beginning of March. I could look at the data from February and January and December and last year as well, and kind of figure out what is coming in the next month or so. So we can look at things in the next couple months and kind of figure out. And the spot market is always so volatile, so you cannot really, hand on heart say that I know what's going to happen in the next 6 months.
Yeah, so if we put that to Pantelis, so I think as we were talking about goal modeling, so this is an example of we understand the goal in a high granularity, and then once we know what the goal is, making digital tools to support it. It's not easy, but at least it's achievable. Something we can actually do is I guess the same things could apply to bunker purchasing and spares purchasing. I guess that's exactly what you're doing, isn't it? Is understanding the shipping needs and
to be able to do, for example, an oil record book, and to be able to also do at the same time a vetting module, you need to be able to understand and model the commercial side and the effects. So an oil record book means that you are going to be recording things that an auditor 5 years down the road might legally check with respect to how many bunkers you did, what were the sort of the measurements of the depth of the ship, what stuff you had in each tank, all the bunker receipts, the invoices. So all these things you need to take into account, and the only way to take into account is to model all this. And again, vetting, the reason that you have to have a good vetting is to ensure that you can charter your ship. So, and the right ship is also vetting for bulkers, so it's vetting for everybody. So being able to understand the real world and the high-end goals of the company means that you can maybe develop a lot better software. Like an oil record book that includes everything from your ISM checklist for bunkering, the bunker summary records, the incinerator records, were you in the port while you said that you took bunkers, that kind of stuff. So there's a lot of things that you need to model to be able to do any software nowadays properly.
oh, very good. Perhaps a sort of question to finish things off on AI. I think there's an almost misunderstanding about what it is and what it can't do. So I saw this press release from Posidonia yesterday. They were saying that 276 companies are making AI and everybody's using it. I mean, my vision, I think it's the same as yours, that where we want to go from 2024 onwards is tools that far better support what people are actually doing. And AI may be part of that, but it's sort of a relatively small part. But the hardest part is to understand the actual work processes and make the data we have fit together, which is more a human task than a AI task. I don't know if Nancy, do you have any? I mean, you probably get asked this all the time, and I guess it's
we actually do use a lot of AI here at Signal. We use it in a lot of areas. For example, even the simple reading of emails. So in order to support all the formats out there, our AI understands and learns from new formats in order to be able to successfully scrape, as we say, process and pull out the relevant information from there. We use AI when we model our forecasting. So in cases where the commercial data is not there, we will still try to predict a vessel's next open position. We use AI for that. So we look at, the system learns as cargoes get recorded, as, voyage movements get recorded, the system learns and kind of looks and says, VLCC is loading in the US Gulf in the last 6 months, seem to be heading all to Korea to discharge. This might change in the next 6 months, but yeah, we do like using AI to enrich and improve our models a lot. Yeah.
Yeah, so the rule of thumb might be you can use AI if you have a lot of structured data, but there's not many places in shipping where you have that. But you have one of those with the charter data and But tell us your thoughts on it.
AI is based on modeling, so you have different models for AI. Like pattern recognition and stuff like that. All these things are based on model, and your AI is only as good as the model you built it on. So that's why a lot of the AI is for very general solutions, and us companies have to look into building appropriate modeling for our own verticals, our own business use cases, and so on.
Do you want to say where you think shipping industry is going to go in the next 20 years, building on this kind of vision?
If I can say, so when we first came out, we've heard a lot the question, you're gonna take the brokers out of the equation, so people are just gonna use your software and be able to do things. We've been around for quite a few years now. That wasn't the case. I don't think you can pull out the human factor from the equation, and especially in Greek shipping, it's all about human relations. So yeah, we will always, I think, play a supportive role in an effort to free up people so they can have more meaningful conversations and they can keep building those human relationships.
So, are you asking this question commercially, or are you asking this question in terms of what will happen to the ships? I guess the ships will have less crews.
Well, the digital
Some
technology,
things will
really,
be,
and how that's going.
some things will be automated. We are going to have a lot of experiments with sort of sales and stuff like that, and a lot of things will happen with the type of fuels we use. But the real answers, I'll tell you after this summer when I'll go to the local coffee shop in my island, Egnusa, in Nuses, where I'll hear the wise people talk about shipping, and then they know much more than I do.
So the digital technology, where do you think that's going to go? We could see far more integrated tools and far better information in front of us, and more on the single pane of glass. And I guess
Yes, there will be a lot of integrations, and there will be a lot of scrutiny with the data, because all these electronic logbooks and stuff like that, and all these verifiers that are coming, and all the ETS and all that stuff, it's gonna cause a lot of maybe I should become a lawyer in shipping, I don't know. And a lot of these things will cause a lot of problems to a lot of people, because they will be recorded, and they will be recorded for prosperity and forever. And you really need to think about what you're doing.
Oh, well, that's fantastic.
As developers as well, not just as business users. Yeah, we have to find a lot of solved problems.
Well, that's great. Well, hopefully we've given people an interesting perspective on where digital technology is going, both on the chartering and operational side. And I think we can finish. I think so. Thank you very much, Nancy.
One last thing. So to add two things, what does all this mean? That we're going to have to be building a lot more software and a lot more efficiently than we're doing now, because right now it's just too expensive to maintain this with all these vendors and all these people.
Yeah. I guess that goes across the commercial side and the operational side. It's we need more shortcuts or easier way of doing things, because it's very expensive, but also we're going to do a lot more with it in terms of supporting people in their work, I think. And well, thank you very much, Nancy and Pantelis, and I shall pass back to
Thank you very much.
I'll pass back to Farah for the closing words. Cheers.
Thank you to our guest speakers, Nancy Dandolos from the Signal Group and Pantelis from Ulysses Systems, and to all our viewers. We'll be sending you a YouTube video link soon with contact details if you have any further questions. Join us for our next webinar, Making Vessel Performance Easier for Crew, on the 21st of March with Vessel Performance Info, which you can book online at our website. Goodbye.
Thank you. Bye-bye.